Hi, I am Piyush Singh and I welcome you to part 4 of this video series on air conditioning. The topic for this video is psychrometric processes in air washers. Air washers are a type of evaporative coolers, but these were not developed aiming to achieve evaporative cooling, but were more focused on humidity control and air cleaning. Many psychrometric processes can be carried out in air washers like heating and humidification, cooling, adiabatic saturation, etc. Carrier used air washers to develop a central air conditioning plant in 1904. Here is a photograph of an air washer. Typical commercial air washers are enclosed, room-like spray chambers through which air being conditioned is drawn. These air washers are usually box-shaped with insulated enclosures on four sides. The other two faces are inlet and outlet for air. The floats are formed by large shallow water reservoirs or sump tanks whose bottoms are often sloped to aid drainage and sludge removal. Here is a photograph of an air washer with the enclosures removed. The incoming air is filtered to remove pollutants using an air filter. The filtered air is then made to flow through a spray of water, and during this flow, air may be cooled or heated, humidified or dehumidified, or simply adiabatically saturated, depending on the mean surface temperature of water. The flow of water is maintained by a water pump. The sprayed water gets collected in the water tank at the bottom of the enclosure. The water level in the sump is maintained at the required level by supplying water lost in case of humidification. The air flowing through the spray of water is then made to pass through eliminators, which remove any water droplets that the air current carries with it. The flow of air through the air washers is maintained using fans or blowers. Here there are two blowers. The outlet of the blowers is connected to the ducts which carry the air to the conditioned space. Based on the understanding of the air washer, here is a schematic diagram of an air washer. Air typically enters longitudinally into one end from large ducts and passes through banks of spray trapping baffles extending from top to bottom. These inlet diffusers provide uniform entering air velocities in the whole washer cross section and prevent the escape of internal spray. At washer's downstream ends, similar eliminator plates or blades eliminate loss of spray in the leaving air. The air passes through a filter into the spray. In addition to the filter, the sprays of water also remove dust, ash, soot, lint, fibers, and most other solid particles while they heat or cool, but also spray paint mist and most non-greasy vapors, fumes, and smokes. This is similar to rainfall cleaning the atmosphere by reducing particulate matter in the air. The directions of heat and moisture transfer depend upon the temperature and vapor pressure differences between air and water. As a result, the direction of total heat transfer, which is a sum of sensible heat transfer and latent heat transfers, also depends upon water and air conditions. This is achieved by controlling the water temperature using a heat exchanger outside the spray chamber. Depending on the water temperature for a given condition of the inlet air, different psychrometric processes as shown on the skeleton of the psychrometric chart can be carried out. These processes will now be discussed in details. The first condition is when the spray water temperature is less than the dew point temperature of the incoming air. In that case, cooling and dehumidification takes place. The air's dew point, moisture content, dry bulb, and wet bulb temperatures all fall. There is a drop in enthalpy of air since both latent heat and sensible heat transfers are from air to water. To continue the process, the water circulated by the pump has to be externally cooled. The second case is the case of pure water recirculation without any heating or cooling. The recirculated water reaches the equilibrium temperature, which is equal to the thermodynamic wet bulb temperature of the air. This happens when the sensible heat transfer from air to water becomes exactly equal to the latent heat transfer from water to air. The air's wet bulb and total enthalpy remain constant. Its moisture content and relative humidity rise, and its dry bulb falls. The next case is the case of cooling and humidification, but more precisely sensible cooling with moderate humidification. This happens when the water temperature lies between the air's entering dew point and wet bulb. The air's dew point and moisture content are raised, but its dry bulb and wet bulb temperatures fall. Also, there is a drop in the enthalpy of air. Hence, the water has to be cooled externally to continue the process. In the next case, the water temperature lies between the dry bulb and wet bulb of the incoming air. It is also a case of cooling and humidification. The net heat transfer occurs from water to air, resulting in a net increase in the enthalpy of the air. Also, the humidification is higher compared to the previous two cases. To continue this process, the water has to be heated externally. This process is utilized in cooling towers. In this case, the water temperature is higher than the entering air's dry bulb temperature. As a result, both sensible heat and latent heat transfer occurs from water to air. There is a rise in the air's dry bulb, wet bulb, dew point and humidity ratio. In order to continue the process, the water has to be externally heated. When the water temperature is equal to the entering air's dew point temperature, then the air's dew point and moisture content remain constant, but dry bulb and wet bulb temperatures fall. There is no latent heat transfer involved and the sensible heat transfer is from air to water. Hence, in order to continue the process, water has to be externally cooled. When the water temperature is equal to the dry bulb temperature of the incoming air, only latent heat transfer takes place from water to air. Hence, the dry bulb of the air remains constant, while its enthalpy and moisture content increases. For this process to continue, the water has to be externally heated. Having discussed all the psychrometric properties that can be carried out in an air washer, let us reflect back on what has been discussed so far. At this point, a question will appear on the screen. Pause for a moment to think of its answer and resume the video. Name 3 psychrometric properties that cannot be carried out using only an air washer. If we look on the skeleton of the psychrometric chart, the processes that are missing here are sensible heat, dehumidification, and heating and humidification. Looking at all the processes that can be carried out, it is apt to say that air washers can work as year-round air conditioning systems. Air washers are generally not preferred for humidifying air streams supplied to occupied spaces, but used in industrial applications. The reason is the concern related to its hygiene. Air washers also occupy a lot of space and are thermally inefficient compared to cooler coils. Usually, air washers are designed for air velocities from 2 to 3 meters per second, but high velocity air washers with better eliminators and larger banks of water sprays are also available in the market. The performance of humidifying apparatus like air washer is measured by saturating or humidifying efficiency, which may be measured as the ratio of the actual drop in dry bulb to the ideal drop in dry bulb temperature. It may also be measured as a ratio of the actual rise in specific humidity to the ideal rise in specific humidity. Now, this equation can be rearranged to this form. The second term here, if you recall from the previous video, is the bypass factor. Hence, the saturation efficiency is equal to the contact factor. For a detailed discussion on all psychrometric processes, watch the video at the link on the right hand top corner and also in the description below. Thank you for watching. Do watch other videos in the series by clicking at the thumbnails or at the links in the description below. Also, provide your feedback in the comment section below.